Solution to 4-mark question that has got two alternatives from the chapter triangles. Both these alternatives are essentially proofs, right? Therefore, very textbook questions. The first one is the proof of the basic proportionality theorem. We'll prove that in this video. The second one is state and prove the Pythagoras theorem. Pythagoras theorem has been tested quite a number of times in the board examinations in the past. So I got video solution to it. So I'll provide you the link to access the video which has the proof for the Pythagoras theorem. Let's get started with the basic proportionality theorem and conclude that in this video. I'm going to read the statement of the basic proportionality theorem, right? If a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points, then prove that the other two sides are divided in the same ratio. Let's get started with the triangle ABC. DE is a line that's parallel to BC. So if a line is drawn parallel to one side of a triangle, DE is a line drawn to one side which is BC. To intersect the other two sides, if DE is parallel to BC, the other two sides are obviously AB and EC. To intersect the other two sides at distinct points, the points where it is intersecting AB and AC are D and E. What we need to prove is that this line divides the other two sides in the same ratio, which means point D divides AB in some ratio, and it's the same ratio in which point E will divide AC. Essentially, what we need to prove is AD by DB is equal to AE by EC. Let's get started. First and foremost, I'm going to draw two lines. I'm going to draw a line BE and CD. Next, I'm going to drop two perpendiculars, one from D and one from E. The line drawn from D that is going to be perpendicular to the side AC. The line drawn from E is going to be perpendicular to the line AB. So we're going to draw two perpendiculars. We'll call them as DG and EF. I'm going to use area of triangles and ratio of area of triangles to basically do this proof. That's the way you prove basic proportionality theorem. I'm going to pick two pairs of triangles and I'm going to compare their areas. I'm going to find the ratios of their areas. Area of any triangle is equal to half into base into height. That's something that's known to us. The first pair of triangle I'm going to take is basically ADE and BDE. Essentially what I'm doing is I've taken this AB, I know D divides it. So I'm looking at triangle AD, trying to find out its area, and I'm looking at triangle BDE and I'm computing its area. Let's start with triangle ADE. Let the base be AD. So the vertex opposite it is E. A line perpendicular from the vertex is going to be the altitude. So half into AD into EF is going to give us the area of triangle ADE. I'm going to shade triangle BDE just so that there is no confusion about what we are talking about. In triangle BDE, I'm taking BD as the base. The vertex opposite it is E. Incidentally, the way it is drawn, D is an obtuse angle, therefore the altitude is going to lie outside the triangle. Look at it, AD and DB are one and the same line. They're essentially dividing line AB at D. So a line from E that's perpendicular to AD will definitely be the same line that's perpendicular to DB as well. So the altitude to side DB of triangle BDE is going to be the same EF. So area of triangle BDE is going to be half into BD as the base. The altitude remains the same, which is equal to EF. So the ratio of the area of triangle ADE divided by area of triangle BDE, half gets cancelled with half. EF and EF get cancelled to leave us with AD by DB. Let's call this as equation 1. What I'm going to do is I'm going to find out the ratio of the areas of two other triangles. The other two triangles I'm going to be looking at is basically triangle ADE with AE as the base and triangle EDC with EC as the base. Let's do that in the next one. So area of triangle ADE, now I'm taking AE as the base. The altitude is going to be drawn from the opposite vertex, which is D, which is perpendicular to AE. Therefore, this altitude is DG. So half into AE into GD. I'll shade this triangle CAD. EC is the base. Opposite vertex is D. AC is a single line which is divided at E. So any line perpendicular to AE will also be perpendicular to EC. Therefore, the altitude remains the same at DG. Therefore, for triangle DEC with EC as a base, the area is going to be half into EC, which is a base, into GD, which is the altitude. In the other case, we had EF as a common altitude. In this case, we are having DG as a common altitude. So half gets cancelled with half. GD gets cancelled with GD. So the area of triangle ADE divided by area of triangle DEC is equal to AE by EC. Let's call this as equation 2. Now let's look at two other triangles. Let's look at triangle BDE and triangle DEC. I'm going to shade it this way, right? This is triangle BDE and the other shading is triangle DEC. If we take DE to be the common base for both of them, because BDE has DE, DEC also has DE, And both these triangles are drawn in between the same parallel, which means their altitude is for the side DE is going to be the perpendicular distance between these two parallels. We know this theorem also because BDE and DEC lie between the same parallel DE and BC and share the same base DE. They will have the same area because half into the base DE into the altitude is nothing but the perpendicular distance between these two parallel lines. So area of triangle BDE will be equal to area of triangle DEC. So let's call this as equation 3. I'm going to go to the next slide. I'm going to pick 1 and 2. From 1 we know that area of triangle ADE by BDE is equal to AD by DB, right? We have realized that because the altitude is a common EF that gets cancelled. Similarly, area of triangle ADE divided by area of triangle DEC is equal to AE by EC. The bases are the only ones which are different. The altitude is going to be the same, DG for both of them. We have proved this in 1 and 2. So therefore, can we say that area of triangle BDE is equal to area of triangle AD into DB by AD? I'm cross multiplying this. I'm taking this to the right hand side and taking this way. So area of triangle BDE is equal to area of triangle ADE into DB by AD. Running through the same exercise, area of triangle DEC is equal to area of triangle ADE into EC by AE. From 3, we have proved that area of triangle BDE is the same as area of triangle DEC because they have the same base and are in between same parallels. So therefore, area of triangle BDE, which is area of triangle ADE times DB by AD, this should be equal to area of triangle ADE times EC upon AE. Both sides have area of triangle ADE, so these can be cancelled. So DB by AD is equal to EC by AE, or we can write it as swap it, make the reciprocal of both of these things. So AD by DB is equal to AE upon EC. This is what we set about proving. AD by DB is equal to AE by EC. Essentially saying that this line D divides the other two sides in the same ratio. Quickly summarize the last bit in a printed form. Area of triangle BDE equals area of triangle DEC. From 3 we have proved that. Now therefore we can say that this part, which is the right hand side of area of triangle BDE, and this part, which is the right hand side of area of triangle DEC, will also be equal. ADE and ADE can be cancelled. DB by AD equals EC by AE, or the reciprocal of that AD by DB equals AE by EC. Second one, alternative, we'll have to state and prove the Pythagoras theorem. The link is provided here. Click this link or paste this link in the URL bar and you'll be able to get the video from which you can get the proof for Pythagoras theorem. Both of these are standard proofs. Get conversant with them. Quite often, I would even go to the extent of saying every other year they're testing one or the other proof. Before you leave, do 2 things. Sign up at online.maxtute.com for CBSE online coaching for class 10 maths. It takes less than 5 minutes in all of 3 steps to get started. And do one more thing. Subscribe to this channel, youtube.com/maxtute, and spread the word about this channel to your friends and classmates.